Welcome to today's physics class. Our topic today is motion. We hear of the word motion every time, but today we want to talk about motion in details and what it actually means. The first thing is, when we say motion, we're talking about a body moving from one point to another or changing his state of rest. If you get into your kitchen, for example, and you have a pot of rice in your kitchen, and maybe the initial position where it was, you just discover that the pot of rice is no longer there. It shows that the pot of rice has gained motion. Or probably, if you keep your phone at your center table, and probably you go out to see someone, maybe you come back, or maybe you forgot the phone, and you discover that it's no longer on the center table, but it's now inside your bedroom, then that your phone has gained motion. So motion basically is about a body or particle changing its position. But this change of position can be caused by an agent. Bodies cannot just change position like that. There is a particular agent that causes bodies to change position. And the name of that agent is called force. Force is an agent that can cause bodies to move from one point to another. And this force is of different type. So automatically, we can write boldly now and say that force causes motion. But before then, I will say, what is motion? Motion is when a body or particle changes its position. When a body or particle changes its position, we say that the body has gained motion. Good. But this motion is caused by an agent called force. This force itself is of different types. There is a kind of force we call contact force, and there's another kind of force we call field force. Contact, and we have field force. A contact force and a field force. A contact force is a force that we are used to. A push or a pull. If I decide to hold your clothes and drag you, you move towards my direction as I drag you. The reason is because my hand is in contact with your body and I decide to pull you. So you will change your position. Then you have gained what? Motion. But in a situation where I decide to push you, you will also move from the place where you were initially to another position. Then you have also what? Gained motion. But in a situation where I don't touch you, I did not push you, I did not pull you, that kind of force is not contact force. But when it's contact force, it is either a push or a pull. A pull or a push is an example of contact force. A force that causes motion due to the fact that the body that is causing that force, that agent that is causing that force, which is force itself, which is the agent, is in contact with the body that is in motion. It pushes the body moves. The body accelerates, the body gains velocity, the body acquires speed. If you pull the body, the same thing will happen. If you push the body, the same thing will happen. It will change its position. It will gain acceleration. It will acquire speed. Because this kind of force is in contact with the body in question. But in a situation where the force cannot be seen with your two naked eyes, but you can only feel it. You can't see the force, but you can feel it. is no longer a contact force. It is now a field force. Okay, a field force, for example, is gravitational field. Let me give you an example. Gravitational force is a field, is a kind of field force. We have electric force, which is electrostatic, and we have magnetic force. Now, you have gravitational force, you have electric force, and we have magnetic force. They are all examples of field force. The reason is because they causes bodies to accelerate. They causes bodies to change position, but they are never in contact with the body in question. You see them acting, but you can't, you feel them acting, but you don't see them. You can only feel it. So a field is a region where a certain force is being experienced. A region where a gravitational force is experienced is called a gravitational field. A region where an electric force is experienced is called an electric field. And a region where a magnetic force is experienced is called a magnetic field. Now, they say that the basic law of gravity states that whatever goes up surely comes down. When you throw a body up, you observe that the body moves up, but the body will still end up falling down. And what is that force that pushes the body down? You don't see the force, but you only experience, and you know that the force is there. When you jump up, something will pull you down. That force is gravitational force, but you can see it. So automatically it's a field force, but it causes your body to be in motion. It changes your position. Then you have gained what they call motion. For the electric force, you observe that in electric force it's a little bit different too. Electric force, you just discover that you put on electricity, you put on your plug somewhere, and you just observe that electricity, your bulbs, your TV, your fridge, they are all working. How did that electricity move from that spot down to, you on your generator, or you put on your generating power, wherever? You observe that electricity moved from that source down to other places. How does it move? The reason is because there is a force that moves that electricity from that point. And sometimes somebody say someone is being electrocuted. Yeah, when you're electrocuted, that is cell effect. Yeah, cell effect is part of it. But you observe that those people, when somebody is electrocuted with a very high voltage, you see the person is being thrown as if it's like piece of paper by the electric circuit. This is electric force. There is a force as those electric charges are passing through that conductor. Now, the higher the voltage, the higher the electric force. Now, for magnetic force, you observe that if you bring two magnets together, as you bring them, you observe that they are trying to attract. They want to come together. And when you reverse it, you observe that they want to repel themselves. So that's why we will say that like charges, they do repel. But unlike charges, they attract. So when you come to poles of magnets, we say like poles repel, unlike poles attract. So when you have two poles, a north pole and a south pole, they will attract. But a north pole will repel. But when they are repelling, you see them pushing each other. You are trying to bring them together, but they are repelling. As they are repelling, your question is, you can't see the force pushing them apart, but you can feel it that there is a force pushing them apart. And that force is magnetic force, and it is a field force. It causes motion, but it's not visible to the eye. You can only feel it. Now, let's move on to the next stage. Let's now talk about types of force. With respect to motion types. Okay. The kind of motion that forces cause. What gravitational field will cause, electric field will cause, magnetic field will cause, is the same thing in variance depending on the quantity of force put into the body as what a push and a pull from a contact force will bring. Because of these types of forces, motion was not splitted into different types, which we now have 4 types of motion. Please. So the 4 types of motion we have is 1. We have what we call translational motion. So the first type of motion again is translational motion, with respect to the type of forces that produces the motion. Now, translational motion is simple. When we say translational motion, we mean a body that just moves from point A to point B. Point A to point B. That is translational motion. A body moves from point A to point B. You kick a ball from one point, it moves from that one point to another point. It's just translational motion. It deals with, translational motion has nothing to do with the direction where the ball was going to, but you just know that it moved from one point to another. The direction is not important. Just it moved from point A to point B. That's what you're interested in. From here you have A down to B. If, for example, you have a boy kicking a ball from this point, and this is another point in the football field, if you kick the ball and the ball lands at this point, then you say that the ball has translated from here to here. That's translational motion. It all has to do with motion from one point to another measured on a straight line. Good. That's translational motion. Examples of body. If you give examples, a ball moving from one point to another, a car driving from bus stop A to bus stop B, a train moving from train station A to train station C, B, it's still the same thing as translate. It has only translated from train station A down to train station B. That is translational motion. But there's another type of motion. That type of motion is called rotational motion. Rotational motion. Rotational motion is simple. It's a kind of motion that has to do with bodies rotating about an axis. Bodies, they are rotating about a certain axis. Like your electric fan. If you look at your electric fan, it's rotating, but it's not leaving the axis, it's just rotating about that axis. It's within that place, it's just rotating, but it's around that axis. That is what we call rotational motion. Example of bodies in rotational motion, I mentioned earlier on, the fan, the electric fan. We can also pick rotational motion from bodies like the Earth. The Earth rotates about its axis, just like some years ago, before Galileo and Isaac Newton came up with their theorems. And I also believe that, we used to believe that there were some very heavy giants that pushed the Earth around, that were outside the Earth, and they were pushing the Earth around. But we later discovered that no, that there is a certain force that keeps the Earth to move in his rotational form, and the name of that force is called centripetal force. So the Earth itself moves in a rotational form around its axis. It's just rotating. Some of you have this Earth bulb at home. When you move it, you roll it, you just see it start moving around. But it's within its axis. It's not leaving that place, but it's moving but rotating about an axis. So that's what we call rotational motion. Example of such is your electric fan moving around about its axis. The second one is what we call the X rotation about its axis. Good. Now, we have a third kind of motion, and that is what we call random motion. Random motion is another kind of motion, but this motion is common among gases. It's common among gases. It's common among things that have zigzag movement. Anything that has zigzag movement is said to have random motion. A random motion is a zigzag motion. The word zigzag, zigzag, is a zigzag motion. So a zigzag motion is a random motion. For example, gases, they don't have a straight movement. When gases are inside their confined space, they collide with themselves. Even when they collide with themselves and with the containing vessel, hence the exact pressure. So because of that, they move zigzagly. That's why their collision continues. That's an example of random motion. So one example of random motion is the motion of gases. The second is, if you start a car or a bike, something comes out of the exhaust. It's smoke. When you see the smoke coming out, they don't travel in a straight path. They travel zigzagly. So the motion of the smoke that comes out of your car exhaust is an example of random motion. So random motion, students, you must take note of this fact that random motion is called a zigzag motion. So when somebody asks you, what is random motion? You say, random motion is a kind of zigzag motion which is unidirectional. Now, the fourth type of motion is oscillatory or vibratory motion. Oscillatory or vibratory motion. Oscillatory motion is a kind of motion that passes through a successive path. We'll take an example of that. If you take a guitar, for example, well, I don't play music, and if you use guitars, if you hit the string of a guitar, you observe that they vibrate. But as they vibrate through a successive path, such that their movement, their path movement tends to, when they are straight, they move like this. But when they are being plucked, when they are being plucked, they move like this. And this kind of motion is sinusoidal. It's sinusoidal because it is what? Oscillatory or vibratory. Now, this is a string that is straight, not yet plucked. But immediately you pluck the string by plucking. When you pluck it, it gives you something like this. It starts moving. That's how your guitar string moves. So your guitar string is an example of bodies that is in oscillatory or vibratory motion. Now, another example of oscillatory or vibratory motion is the motion of matter molecules. Matter, you were told that is anything that has mass and occupies space. Correct. Solid has molecules. The molecules of solid are moving, but the motion is slow. But the kind of motion that they have is what we call oscillatory or vibratory motion, because they move, but they don't just move, they vibrate about their axis. They vibrate about a fixed point. thereby creating a successive path as they are moving up and down, but within a successive path. They move, but the movement is very slow. That is why in the principle of matter, when you hit a solid, the solid molecules gain energy to break out of that their fixed point. Hence, they will now become liquid, which is a little bit freer than the solid molecules. So from liquid, when they gain more energy from the liquid state, they now become gases. So the molecules of solid, they move about their fixed point, and the kind of motion is oscillatory or vibratory. Now, the third example, which you are very used to, is something we call the simple pendulum. The simple pendulum is an important invention in the world of physical analysis. The simple pendulum is something of this nature. You have something like this. It's just a bulb. It is a string, something like rope, something like the ones the tailors use or thread. Now, if you swing this, it's at rest. By the time you swing it or release it slightly, you observe that you have something like this. You get something like this. So from here, it will swing round, it goes, it returns, it goes, it returns, it goes. And when it gets to this place, it will stop momentarily at rest. At that point, we will say that the body has something they call maximum potential energy. But when it gets to this place, it is at its highest speed. We say it has its maximum kinetic energy. And when it gets here again, it gets back to its maximum potential energy. So this body, called the simple pendulum, that's the name, simple pendulum. So this body is moving in successive paths, to and fro, in a successive path, to and fro, in a successive path. That kind of motion is oscillatory or vibratory. So I have three examples on oscillatory or vibratory motion. One, the motion of matter molecules. They are in vibratory or oscillatory motion. Two, the motion of a simple pendulum. And the third one is the motion of the block string of a guitar. Thank you. Now, that is types of motion. Now we're going to talk about there are parameters used to describe motion. You cannot just motion. A body changes its position from one point to another. There are some parameters that we use to describe this motion. And the first parameter is position. Position. And from our definition, you take it. Position is the place or point occupied by a body or particle at a particular time. So the position is the place or point occupied by a body or particle at a particular time. So this position can be determined using locational tracing. Locational tracing is done using what we call distance between 2 points. Distance between 2 points. Okay. Now, for example, I have a point here, A, and I have another point here, B. I want to locate their position. Position A, position B. The first thing is that I have to find the distance. I want to find the distance between point A and point B. It's easy for me to do that. How do I find that distance? All I just need to do is to take my torque. If I take these two torque out, I'll locate this one, and I'll locate this. I'll locate this, and I'll locate this. If I can locate the two of them, I will have somewhere here. What I have here, I'll call it Y2. What I have here, I'll call it Y1, because this is the Y-axis, and this is the X-axis. But what I have here, I'll call it X1, and I'll call this X2. Because this is the lowest X, so it's X1. This is the highest X, so it's X2. This is the lowest Y, that's why it's Y1, and this is the highest Y, and that's why it's Y2. So I want to find the distance between the two of them. So what I just need to do is simple. I will tell you that the distance AB is equals to square root of x2 minus x1 all squared plus y2 minus y1 all squared. Please take good note of this as a formula. So from there, I will call this formula 1. So I'll be naming the formulas. So this is distance between 2 points. That's locating points. Distance between 2 points of two bodies in different positions. Oh, let's take a question from here. What is the distance between point and arrow so take this as solution. It said, what is the distance between point A 42 and arrow 51? We're going to solve that now. First of all, if you look at the question carefully, you observe that point A has 2 points. Point B is located also with 2 points. And that 2 points is easy for us to find it. One of them is called x-axis, and the second one is called y-axis. But there are other names you can call them. This first one, that's x1. This first one is called ordinates. And the other is called abscissa. You call one ordinate, you call it the other abscissa. But the thing is, it's better for you to say this is x axis and this is y axis. Simple. So when you're treating, you just say x axis, y axis. But always remember, the x axis comes first before the y axis. So if I write A as 42, what does this mean? It means that this is x and this is y. That's what it means. So from here, solution for my question, what do you get? The distance A arrow now will give me square root of x2 minus x1 all squared plus y2 minus y1 squared. Now let's go. How do we know which of the values x2 and which of them is x1, which of them is y2 and which of them is y1? That becomes a question. Now, that's not difficult. What you do is that you pick this out, 42, and the other is arrow 51. The first value here is x, so we'll call this x1. This is y1. This is x2, and this is y2. Simple. So the first one is x1, the second is y2, y1. This one is x2, and this is y1. You can also reverse it. You can decide to take arrow 5-1 first before this. So in that case, it's reversed. This can also be x1, y1, x2, y2. So let's go. So from here, you have square root. What is here? That will give us 5. And the next one is 4. From here, we have 5 minus 4. That's 4. x2 minus x1. Now when you get to y2, so y2, you have values like 1 minus, and y1, you have 2 raised to power 2. From there, you can take your calculations back by saying 5 minus 1, that's 1 raised to power 2, plus minus 1 raised to power 2. That gives the value directly. 1 square is 1, minus 1 raised to power 2 is also 1. That automatically becomes square root of 2, which is, or you can say 1.414, whatever. That gives the value of a arrow, the distance between point A and point arrow. Good. Now, the second parameter after position is, we want to talk about another parameter. Position is one of them. The second is something we call distance. It's used to describe motion. Distance. Distance is simple. Is the length measured in meters from one point to another during motion. So, distance is the length measured in meters from one point to another during motion. But there is another one. You call it displacement. Displacement. Displacement is the distance measured in a specified direction during motion. So the difference is, distance is the length measured in meters from one point to another during motion. Displacement is the distance measured in a specified direction during motion. This is the difference between the distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. What's the difference? The distance from Lagos to Ibadan, if for example is 200 kilometers, for example, what I've measured is distance. But when I say the distance from Lagos to Ibadan is 200 kilometers in north 56° east, this addition is called direction. This is magnitude, but this is direction. So this is distance, but this is displacement. So distance is just 200 kilometers. Displacement is 200 kilometers in north 56, the east direction. Meaning, when the direction of a distance is shown, it is no longer distance, it is now displacement. So magnitude and direction, only magnitude. Only magnitude is a scalar quantity. But with magnitude and direction, it is displacement, which is a vector quantity. So distance and displacement. So displacement is distance measured in a specified direction. Now, other parameters we want to talk about is speed and velocity. So let's see speed. Speed is distance divided by time. And we have velocity is displacement divided by time. So this is a scalar quantity, while this is a vector quantity. So you see, velocity is displacement divided by time, while speed is distance divided by time. There are parameters used to determine motion of the body. And the last one is acceleration. Acceleration is change in velocity divided by time. So the change in velocity divided by time. So it's acceleration. Now, these are terms used to describe motion. But the acceleration is on both sides. When the velocity of a body is increasing with time, the velocity is increasing with time, it is acceleration. But when the velocity is decreasing with time, it is called retardation. So that one is called retardation. But retardation also have another name. It's also called deceleration. So when the velocity increases with time, acceleration. The velocity decreases with time, deceleration. So these are the terms used to describe motion. Thank you very much. And that will be the end of this particular class.